Hi! You might have seen Mr. Who's the Boss's 10 million subscriber special, where he unveiled a new phone storage system made by Matt from DIY Perks. Had some cool LEDs on that. I wrote the code for it. So today I'm going to go over how I wrote it, what was needed, how I went through the problems and everything, just to kind of give you an idea of what it's like to write server code. If you're interested in that, specifically to deploy on something like a Raspberry Pi. So, let's walk backwards from what we want this LED controller to actually do. We want someone to be able to control it remotely, wirelessly, most likely, and preferably from a phone. We also want that LED controller to then control the LEDs. So let's start by getting the hardware talking to each other, and let's start with the LED control. Luckily, we're going to get a bit of help from Adafruit. They've already made a library that lets us directly control the LEDs, and as many as we want at a time. So we're not going to have to worry about directly interfacing with the LEDs. We can simply just tell this library what we want it to do, and it will just make the LEDs do that, which is going to save us a lot of time. Alright, let's focus on this piece of code up here. It's nothing more than initial configuration. We're just setting up our database and a whole bunch of other things just so that we don't have to deal with it further on. And we have one central place we can just change these generic variables. It's really handy to have these kinds of things either in a config file or just in one area so that you can just quickly go back to it and change it. It's really useful. And all we're doing here is initializing our database, setting the amount of pixels that we have in this whole shelf, doing the group size, group pixel size, and the tail size. This is more for me making custom animations. We're also doing order and the pixels, which are just stuff specifically for NeoPixels. This is like initializing the RGB order and actually setting up the controller for the actual pixels themselves, straight from the Adafruit controller. Okay, cool. So we have the LED set up now, and we've got everything configured to a place we're happy with. So let's actually start using the LEDs. Before we get too deep into that, though, we want to think about how we're going to use the LEDs. We're going to be doing stuff with them while we want the server to be running. And the simplest way to do both is to use multi-threading. Normally with multi-threading, you would start a thread, have it do what it needs to do in the background, wait for it to finish, and just resume the main thread. But in this case, we want it to be running continuously, but we still need a way to cleanly stop it, right? So that's what the stoppable thread class does. It allows us to start and stop the thread on request without creating any errors or forcing it to throw anything. It's just a nice, clean way for us to interact with the thread without directly forcing it to stop or killing the thread abruptly. Now we have a way of running things outside the main server process. Let's put that to good use and run the idle animation. For that, we have this function right here, which does nothing other than run the Adafruit rainbow animation until it's been told to stop. That's what the while loop is there for. It's extremely simple, it gets the job done, and it's a pretty clean implementation, if I do say so myself. Of course, this print doesn't need to be there. It's just there for debugging purposes, just to make sure that we know that the thread is running. You don't actually see that. That gets printed to the service log, but you don't ever see that. I've gone over the idle animation. I'm gonna skip over a whole bunch of these functions. Almost all of them are database management math or animation math. All of them are pretty low level and pretty boring, so I'm going to do you a favor and skip over them. If you do want a closer look at the code, however, it will be posted in the description, or if you want to ask a question, post one in the comment section. I'll most likely read it and get back to you. A lot of this is pretty simple stuff, so it shouldn't take too long to explain if you do want a video on it as well. Alright, just before we get to the server code, I'm going to do a very, very brief and quick explanation on the actual lighting animations that I wrote, or animation singular to be precise. So this first one here, scan 2, it does one job. It was supposed to be more complex, as you can see by the commented out code below, but it has been simplified to its basic form, really. A lot of the code didn't work on the day, so I ended up having to either comment it out or rewrite it, and this was one of those functions. So at the minute, what it does, it takes the position of the phone that it receives, and then it will find the group that that phone is in. Now, the reason we're doing it in groups is because a lot of the actual position of the phones didn't line up to the amount of LEDs we had. So we had to kind of group the phones into a group of 3, and then light up that group instead of the individual phone. You can't actually tell in the video with Mr. Who's the Boss. In fact, the angle lines up perfectly so that the glint actually appears on the phone that it's supposed to. I think that happened by chance, but it worked out really well in the video, but in person it will light up 3 of the phones. So in this case, it will find the group and it will go through all of the pixels until it hits the group that the phone is in, and it will keep that lit up for 30 seconds before resuming the idle animation. The way it does that is simply by literally just blanking out after 30 seconds and then letting the request handle returning to the idle animation. It's a similar story for this light position function here. It does exactly the same thing, just without scanning to the LED first. It literally just lights up the group, and then we'll keep that lit for 30 seconds before ending, essentially. Alright. So we are kind of done now with the setup for the different animations. It's time to actually put them to use and use them in the server. So if we go down here and we go to all the different requests, you can see here we have get request called get phones, edit phone, delete phone. These are kind of like our basic CRUD stuff. Our create is further down on post to index. So we have our create, which is again down at the post on index. We have our update, or read, sorry, which is our get. We have our update, which is our edit phone, and we have our destroy, which is our delete phone. That's your standard CRUD stuff. And since all we're managing is phones, that's all we really need. And then we have our 2 different animation or lighting requests here, one called light position and one called scan to. Both of these run their respective animations, so the scan to will run the scan to function, and the light position will do the light position one. Again, the scans to the actual position, and the light just shows it for 30 seconds. Once both of those are done, they literally just resume the idle animation and return 200. Nothing too complex here. Again, it's your standard web server stuff. Just kind of boiled down into an extremely small package. This is thanks to Flask. Flask actually made this very, very simple. It did take a while to learn because I haven't used Flask before, but this was actually quite nice. Again, this commented out section here was actually for a feature that didn't actually get implemented into the final shelf. This was supposed to be for a door lock, so you're supposed to actually be able to unlock and lock the shelf from the web app as well. But unfortunately, Matt couldn't find a way to get an actual door to work, or at least work the way he wanted it to. So this kind of got left, but the code's still there if you want to use it. Again, I kind of refactored since I wrote this, so as you can see, it probably doesn't fit the exact same way, but it should still work. Other than that, that is it. It just runs the web application from there. The front end's written in raw HTML. There's nothing special to write home about that. Again, you can check it out in the description. Sorry, the link will be there for you to peruse and explore the code yourself if you really want to. But that's about it. I don't really have much else to talk about for this. Alright guys, thank you so much for watching the video. I think that's where I'm going to leave it for today. This is my first time doing a talk-to-camera explanatory video, so I appreciate your patience waiting over a month for me to get the video out. Again, I wasn't intending on making a video before, but kind of found myself wanting to the more I watched the videos back and while we were setting everything up. So I've kind of had to learn my chops again and get back into editing. So I do appreciate you guys waiting so long, and I do hope you take a look at the code in the description, subscribe, follow me on Twitter for any more updates. I do plan on making more videos, just not sure what on yet. I do a lot of 3D printing, coding. I'm looking into getting back into making stuff as well. So we'll see what happens. Hopefully there'll be some more content from me on a more regular basis at some point, but who knows yet. I have yet to put down a plan. So do bear with me for a little bit longer while I get everything sorted and situated and get myself ready again. So thank you so much. I appreciate it very much, and goodbye.